Hello everyone, I'm Sparshit and I'm an educator at Relevel. Today we'll be looking at this problem called the beautiful necklace. Let's get right into it. Okay, so this question seems to be of the type where we need to understand the problem statement in depth, and if we are able to do that, the implementation will not be very hard, right? So let's go through the question and understand the test case and then come up with the approach and then we'll code it. Okay, so let's start. Uh, Richie went to a market selling necklaces. He wanted to buy a beautiful necklace for his mother. He knew that his mom would become angry if he spent too much money on the necklace, but he wanted to buy the best necklace for his mother. So he decided to buy two necklaces and merge them to make the necklace with maximum beautiness. Okay, so this is the problem, but there would be a code version of this. So there are a total of n different necklaces in the market, and each necklace has the same number of stones m. Each stone j in necklace I has beautiness value p of ij. Right. So if you have to understand this, there would be n different necklaces, right? And each necklace will have the same number of stones m. So if there are n and if n equals to 4 and m equals 5, that means there would be 4 necklaces with 5 stones each, right? And each stone j in necklace I has the value has a beautiness value b of ij. So we'll also get beautiness value of each stone in every necklace. Now, how do we compute the beautiness of a single necklace? The beautiness of a single necklace I is the minimum value of all of the stones in the necklace. So if you have beautiness value bij for every stone, then the total beautiness of that necklace would be the minimum value of all across all stones of that necklace. So if, for example, if the necklace had 3 stones, each of beautiness value 1, 2, and 3, then the beautiness of that single necklace would be 1, right? Because 1 is less than 2 is less than 3, right? Richie wanted to give his mother a necklace with maximum beautiness, so he bought 2 necklaces with index ij. So if there are 5 necklaces, he bought 2 necklaces instead of 1 necklace. So now the beautiness of the combined necklace is min of max of bi comma 1 comma bj comma 1 bj of 1 comma max of bi2 comma bj2. Okay, so we'll understand what this essentially means. This essentially would mean that if I took 2 necklaces, I would be looking at index of each necklace. So let's say the first stone with necklace 1 with first stone with necklace 2, and I would be comparing the maximum of these two values, right? And so on and so forth for every index. Second stone of necklace 1 with second stone of necklace 2, and so on till nth index of necklace 1 with nth index of necklace 2. And then because we know that now both of these are merged together, like we've just discussed, the beautiness of this necklace would be the minimum value across all of these values, right? So we'll be able to understand this better with an example. So here sample input would be first line contains the integers n and m. Like we have discussed, n is the number of necklaces and m here would be the total number of stones in each necklace, right? So if we take this example, there are 5 necklaces here with 4 stones each, right? So let's look at this. I've just written down the test case here. Right. So if he chooses these 2 necklaces, hypothetically, let's understand what is the computation that happens and how do we determine that if he chooses these 2 necklaces, what will be the total beautiness of this combined necklace? Right. So what did we say? We would first have to take stone at each index. So we have to take 2 and then 1, right? And then we have to take the max of max between these two, right? The max of these two would be 2, right? So let's take 2, right? That would become the new necklace new stone that has been combined, and that stone ka value would be this, right? So the next would be 1 and 4, max between 1 and 4, which would be 4, right? max between 8 and 3 would be max between 9 and 8 would be 9, right? Now, the beauty of this necklace, this combined necklace, will be min of these values, right? And this will be min of 2, 4, 8, 9 would be 2, right? So the beauty of this combined necklace, therefore, is going to be 2, right? I hope what operation we are doing while combining necklaces and finding out the beauty of the merged necklace is clear. Right, now that we have figured out what to do to figure out the total beauty of a necklace, when you combine two necklaces, how to find out the beauty of the merged necklace, right? So let's say we get a value A, 1 for this combination. So now similarly, we need to go through every possible combination, right? Let's name this necklace 1, necklace 2, necklace 3, necklace 4, necklace 5. Right? So we've just gone through 1 to 2. Let's call this A1, 2 maybe. Right? Now we need to go through what will be the beauty of the merged necklace if I merge 1 and 3. Now the thing to notice here is that once we have done 1, 2, 1, 3, 1, 4, 1, 5, 2, 1, 3, 1, 4, 1, 5, 1 is the same value. So therefore A1, 2 will be equals to A2, 1, right? Because we are taking the max value of this and this between this and this, regardless of whether I'm comparing 1 or 2 or 2 or 1, that max value will remain constant. So essentially, we don't need to, once you have iterated this way, we don't need to check these combinations again. Right? So essentially, you will have to do 1, 2, 1, 3, 1, 4, 1, 5. Then you will have to do 2, 3, 2, 4, 2, 5. Then you'll have to do 3, 4, 3, 5, then 4, 5. Right? So you will have lots of values here. Then you will eventually get A of 4, 5. Right? So these are all the possible necklace combinations that you will get with this value being represented as the beauty of the merged necklace. Now, our objective, as we have noticed here, is that we essentially need to get the maximum value of the beautifulness. Right? So if we need to get max value of beautifulness, we just need to do max of all of these values. Do max of A1, 2, A1, 3, which is all these combinations, we will get max beauty as the answer. So I think this is fairly straightforward now. Now that we have figured out we have figured out two things essentially: how to merge two necklaces and find the beauty of the combination. What are all the possible all such possible combinations? And the way to get the answer here would be simply to take the max of all of these values in the number. Right? Why? Because we want to get the min value. So if any number is less than result, it will get set to that as part of our iteration. Right? So now what do we need to do? We need to go from k equals to 0 to k is equal to 0 to k less than m in this case. Why m? Because we need to loop through the number of stones in this case, right? Because we already have I and j, which represents each necklace. Now we need to visit every stone in each of these two necklaces, right? So we are going to say result will be math.min of result, comma, math.max between stones are in corresponding same positions in both necklaces, right? So we need to say necklace data of two values. Let's write these down first so we can then go through what two combinations we need to take. So what does necklace data represent? It represents first which necklace it will be and then which stone it will be in the jth column, right? So we'll say I want to take necklace data of I and necklace data of j, which will represent the two necklaces. Then I need to take the two stones in the same position, which would in this case be k, right? And then return the result. Right, so what is happening here? Let's go through this code again. So for example, let's take the 0th iteration here where I would be 0 and j would be 1 in this case because j is equal to I plus 1, right? So in check combination, what will be the value of I and j? I will be 0 and j will be 1, right? So when it comes here, result is set to max possible value of number, right? And then let's say k equals to 0 in the first iteration. What will essentially happen is we will take the min of result, comma, max of necklace data of I and k. In this case, like we have discussed, would be 0. So 0 of k is also 0 in the first iteration, right? So it would be, we are considering the element 2 in this case, right? And we're comparing 2 with necklace data of j of k, and j here is 1, right? So we are considering 1 of 0 because k is still 0. If we go back to this, that's essentially what we want to compare. We want to compare 2 and then we want to compare 1, right? And then in the next iteration, k becomes 1 because of k plus plus, and I and j still remain to be 0 and 1, right? So in this case, k is also 1 now. So in this case, we would compare in this code block, we would compare 1 and 4, right? Exactly like how we compared 1 and 4 here. Right, after we have gotten all of these values, we are then doing a min between 2 and 1 and 1 and 4, like we have done here as well. Right, we said the max of 2 and 1 and then the min of all of these values, right, which will essentially give us the result. So we have done two things. We have taken every combination of necklace and then we have gotten the beautiness of the necklace if we combine these two, if we combine any two necklaces, and then across all of them, we are taking the max to give us the answer. Okay, so now that we have successfully implemented our solution, let's try and run it and see if we are getting the expected output. Now, what should be the expected output? We have discussed here that the sample output should be 3. Why should it be 3? Because amongst all the combinations, the max beauty of the resultant necklace would be the combination of this and this. Because if we take these two necklaces, quickly let's go through them again. Let's go through the logic again. It would be max of this comma this, whereas in this case it would be 3. Max of 9 comma 4 would be 9. Max of 9 and 3 would be 9 again. Max of 8 and 6 would be 8. So now we need to find the min value of this merge necklace, which would be 3, 9, 9 and 8, and the min of these values is of course 3. Right, so let's try and execute this and see if we're able to get the value 3. Then we have successfully implemented the problem. Right, so the value is actually 3, and therefore we were able to implement this solution. Right, so what did we learn? We learned two things. We learned first we need to invest time in understanding the problem statement, and after that the implementation becomes very easy. So we split it into two parts. First, we said let's break this problem down into finding out all possible combinations of the necklace, right, which we achieved via this, going via I and j plus